See my screen?
Yeah.
Okay. So what is the need of classification of elements? First, this is the question which is there in front of us before starting this chapter. So why do we need to classify elements? That is the first thing we need to know. And suppose if we look at the number of elements in 1800, there were very few elements. In 1865, there were 63 elements. Got it. And they kept on increasing.
Okay.
And today, the periodic table is complete.
Hello, sir.
Yeah, Nabila, good evening. So we have just started with the periodic classification and properties of element, right?
Okay, sir.
Today we have 118 elements. Okay. Many elements are actually man-made synthetically in nuclear laboratories. Okay. And they are mostly the elements after 92, atomic number 92. Got it? After uranium. They are not natural, they are mostly synthesized in the lab. Okay. So the problem is with so many elements, it becomes very difficult to study their properties there, because so many elements are there, their compounds and all. So this actually forces us to devise some method of classification of these elements. So this, I hope, is clear to you. What is the need to systematically study the properties and the compounds of various elements, right? Maha and Nabila. So this is the basic thing. And there were earlier attempts also. For example, there were earlier attempts of Doibriner triads. So any one of you can tell me what they are? Any idea? Triads. It seems familiar. So what do you mean by Doibriner triads? So Doibriner actually classified the elements into group of three. Okay. So three elements were actually classified. So he identified certain groups of elements. And out of these group of three elements, when they were arranged in increasing order of their atomic masses, Got it. So three elements were identified. Clear?
Yes, sir.
And the group of three elements.
So what were the three elements?
Pardon? No, actually there were three elements, set of three elements which were actually uh, identified from the known elements at that time. Okay, and when they were arranged in the increasing order of their atomic masses, what was found? It was found that the atomic mass of the middle element was the in the mid was the average of the atomic mass of the first and the third element. Got it? Is it clear? This is
Yeah.
one thing. And the other thing which Doiberiner noticed was that the properties of the middle element were also resembling the properties of the first and third element. So group of three, so all these three elements were having similar properties, okay? And the properties were actually linearly varying. Like first element has some properties, so second element will have some more of that property. Third element also will have those properties by more amount, okay? There is a uniform variation of the properties. And on the basis of properties, these elements were collected together, or they were segregated together. So three elements were identified and they were arranged in increasing order of their atomic masses, and three elements having similar physical and chemical properties. Got it? What do you mean by triad? Any idea what do you mean by triad? Triad means set of three. Got it? So that's why so triad, three elements. That's why the name triad. Okay. So I will give you the examples of those three elements. What would those three elements? Okay. These three elements are like lithium, sodium, potassium. Got it? These are the three elements, let's say. Atomic mass is 7, 23, 39. Got it? And we know that these elements have same properties. Is it clear or not?
Yeah. Yes, sir.
So not only this, there were other elements also identified like calcium, strontium, barium. So very simple way of classification. So these also have the similar properties. And if you take the average of the first and the third element, that is 40 plus 137 by 2. Got it?
Yes,
Yeah.
sir.
It is coming out to be 88. So at least we have something instead of nothing. Okay. At least something is better. Some classification is better instead of nothing. That at least we are having three elements. Got it? So
Okay.
that's the thing. But actually, if we look, they have similar properties. You must be knowing. You must have studied in your class 10th alkali metals. Like they react with water and they are soft in nature. Okay, alkaline earth metals. Okay. But what is the drawback? The drawback is they were not applicable throughout the periodic table. There are so many elements, and it is very difficult to have three elements every time. Okay. So basically, it is very difficult to have it applied on all the elements. Okay. And there were many elements which were found that which do not have, which had similar properties. And this law of triads are not applicable. Okay. For example, if you have uh, iron, cobalt, and nickel, what are the atomic numbers? Today we know. Okay. That is 26, 27, and 28. Okay. So this is the mass number of 56. You can see that the mass number of the metal element, it is coming out to be more than the mass number of the first average of the masses of first and third element. Okay. So this rule was not applied everywhere. That's why it was dropped. Okay. Next method which was used, there were many scientists who tried to figure out how to classify the elements. We are discussing the most common one. The most common one, this you may have studied, Newland law of octaves. Have you studied it in your 10th class?
No.
Okay. So basically it is octave means set of 8. Right. So in the music we have octaves. So every eighth note in the music resemble the first note. Okay. So similarly, here also the properties, the elements were arranged in increasing order of their atomic masses. Okay. And when they were arranged in increasing order of their atomic masses, it was found that the every eighth element has the property resembling the first element. Got it? Is it clear?
Can you repeat it, sir?
Yeah. So Newland arranged the elements one very important thing. All the previous classifications and the modern classification is that all the previous classification were based on atomic masses. This is very, very important. But the modern classification is based on atomic number, that is the number of proton. All these previous classifications, as you can see, they are based on atomic masses. Okay. That's why I'm underlining this is the first thing you should keep in mind. Okay. So what Newland did, Newland also arranged the element which were known at that time in increasing order of their, what should I write? Of their
Masses.
atomic
Mm.
masses, right?
Yeah.
So all the elements were arranged in increasing order of their atomic masses. Okay, and there were 8 elements, set of eight elements. Octave means 8. Okay, were arranged, and it was found. Okay, so like the notes in music. Okay, uh, they keep on repeating, and the eighth note, uh, it appears very similar to the first note. So likewise, the elements also, properties, when they are arranged in increasing order of their atomic masses, the properties of the every eighth element was similar to that of the first element. Okay, so Newland thought that there may be some relation to that number 8, and just like the music, the properties of the elements are also getting repeated after the eighth element. That is, after eighth element, that is will actually similar to that of the first element. Okay, let me write them. But there is a thing which we should keep in mind. So these are the elements I am writing, and I am writing the elements with similar properties one below another. Got it? As you can see here, the elements with the similar properties are written one below another. Okay, so if we start with lithium, beryllium, boron, carbon, oxygen, fluorine, then sodium. So every eighth element is placed below the first element. You can start it from anywhere. If you start it with boron, carbon, nitrogen, oxygen, chlorine, sodium, magnesium, and aluminum. If I start with boron, so after that the eighth element will be placed below the boron. It is because they resemble in their chemical and physical properties. Okay. So this is the Newland laws of octave. But this Newland law of octave was not valid throughout the periodic table. Okay, why it was dropped? Can you see one very big thing missing in this, in these elements? Anything which is missing?
Argon.
Yes, exactly. So at that time, what happened was noble gases were not discovered, right? And noble
Oh,
gases were
okay.
not right. So that's why the eighth element, neon, is also missing. After fluorine, we have the neon, the 10th element, right? So it appeared to be that eighth element has similar properties as compared to that of the first element. That's why the every eighth element is coming below the first element. Okay. So noble gases were not discovered at that time. That's why they were not included in this classification. So once you include them, you will notice that this theory is wrong. Got it? It's not valid. Okay. After that, if you include them, the ninth element will match in properties with respect to the first element. So that the resemblance of properties with octaves of the music is not true. And this whole thing actually fails after calcium, not applicable after calcium. So after calcium, so he tried to fit in somehow the rest of the element, but that fit was actually not a proper fit. Actually, that fit is basically just he was trying to push his law, but actually it was not obeyed. Got it? So this law was abandoned, right? And not adopted for the later stages of classification. But it is actually a bit more improved than the Newland law or that Darwinian law of triads, which had only three elements. Okay, now we have at least the variation of properties from up to eight element, and the seven element and the eighth element has the property similar to the first element. Got it? Is it clear?
Yes, sir.
So Newland law of octaves, so this was also dropped, and new law came in. Actually, there were many other laws, okay, but they were not very significant at that time. Two most significant people worked together, and one is Lothar-Meyer curve. Got it? And the other person is very famous. All of us know him, and that was Mendeleev. Mendeleev periodic table. Okay. Both were contemporary. Got it?
Yes.
So Lothar-Meyer curves. What Lothar-Meyer did, actually, he took some property of the elements, right? And what he did, he plotted all the elements, that property of the elements graphically with the increasing order of their atomic masses. Got it? Is it clear?
Yeah. Yes, sir.
So increasing order of the atomic masses, they were arranged, and it was found that the elements having, suppose the graph pattern is like this. Okay, it was like this. Let's say for the size. So similar elements are occupying similar positions on the graph, and that similarity is being repeated after a certain period of atomic numbers, after certain atomic numbers. Okay. So let me write it and let me explain it in detail. Okay. So he plotted some graphs of what? Properties of the element versus their atomic numbers. Okay. Lothar Meyer plotted the physical properties. Plotted the properties of various elements. With respect to their atomic masses, increasing atomic masses. Okay. And he found so let's say suppose there are some elements which are having similar properties. Okay. And so when he depicted the value of that properties graphically, the same type of elements are occupying same positions on the graph. Okay. Let's see how it is happening. For example, let's suppose if we plot the atomic volume. Atomic volume means the size. Got it?
Yes, sir.
The size of the various elements and with respect to the atomic masses. Just keep in mind that all these previous classification were based on atomic masses, atomic mass number, right? Number of protons and number of neutrons,
Yeah.
sum total of, right? So this is just like the plotting the size of the various elements, okay, on the basis of their atomic masses. So let's see how it has happened. So we were having this kind of graph. So let's say suppose if you are having sodium, right? Then you have magnesium, then you have aluminum, got it? And so on. Similarly, you have potassium, okay, then you have calcium, right? And you will plot the subsequent element. These are the transition elements: scandium, titanium, vanadium, chromium. Got it? The various other elements: rubidium, strontium. Now in the periodic table, we know that sodium, potassium, rubidium, they are just one below another, and they are all alkali metals. Got it? On
Yes.
they are actually the first column of elements: lithium, sodium, potassium, rubidium, cesium. Clear? So these are the first set of elements, and they have similar properties. And on the graph, we can see that they are occupying same apical positions on the graph. Got it? This is because they are having the largest size. If we move to the next element, that is magnesium, calcium, strontium, barium, okay, they are actually occupying the descending side of the graph next to the apical position. Okay, likewise, different elements were observed. It was observed that different elements had that different that they are occupying the similar pattern of, they're showing the similarity in the pattern of position being occupied on the graph when these elements were arranged in increasing order of their atomic masses. Okay, this shows one thing. That shows that there is a repetition of properties. For example, the size, it is getting decreased, then it is increasing, getting decreased, then it is increasing. So there is a repetition of properties. Repetition means there is a periodic repetition. That's why the name periodic properties. Got it? Is it clear?
Yeah. Yes, sir.
But but the drawback was this is very perfect thing which Lothar did. But the drawback is actually uh, uh, that it is very difficult to have all the properties simultaneously studied together, because for each property you will have a different graph. Clear? So many elements are there. It will be difficult to study the a lot of graphs every time for different elements. Otherwise, the thing is very perfect. The representation is very perfect. We can have different properties like densities, melting points, got it? So that can be plotted. It for a common person, it is very difficult to remember the graphs and all, and there are so many graphs to remember. So that was the only drawback of this. Okay. So what was the drawback? Okay, difficult to remember all the graphs. And the properties. Got it? Clear. So this was though it was correct, but it was actually not being applied in the regular use, because very inconvenient to have all the graphs every time being analyzed, difficult to analyze together. So at the same time, Mendeleev was also working on the, both were contemporaries. Okay, Mendeleev was also working on these periodic properties, but Mendeleev had different chosen different way to represent them. Okay. But actually, the method of representation which Mendeleev took, uh, that is still being in use. Got it? By that we are using it now. So Mendeleev periodic table is actually a precursor of the modern periodic table. Got it? Is it clear?
Okay.
So,
Yes.
so all
Yes.
these elements actually, so what Mendeleev did, so he represented the elements and variation or whatever in the form of a table. Okay, table has various columns and rows. Elements are arranged in various columns and rows. Okay, so we have a complete chart of the elements which were present at that time in the form of a table, and it is a very good way to represent all the elements in the form tabular manner. So this is actually a very good method which continued later on, but it had some drawbacks. Okay, but actually it is the precursor to the modern periodic table, right? So let me show you how. So first thing is What is Mendeleev periodic law? It means what was the basis of classification of elements which was used by Mendeleev. Okay, Mendeleev periodic law, that as I told you, all these previous classifications were based on atomic masses. Only the modern classification, present day classification, that is the only classification which is based on the which is based on your atomic numbers. All the earlier people used to measure the mass of the elements, and they took that mass to be the basis for classification. So Mendeleev periodic law is also the same. It is based on atomic mass, but you need to write it physical and chemical properties. Physical and chemical properties of the elements are the periodic functions. Of their atomic masses. Got it?
Yes, sir.
Same atomic masses everywhere up to Mendeleev, we need to know the atomic mass. So what do you mean by periodic function? You may be having very quickly, very soon you may be encountering it in your mathematics also. Or maybe you're in 10th class, you may have seen. So what is periodic function? In physics also you may be using it. Any idea? Maha, Nabila? Periodic function of their atomic masses. Physical and chemical properties are periodic functions. So what do we mean by that?
I don't, sir.
Pardon?
I'm not sure.
Yeah, means they get repeated. Okay. Something, look, in the above graph also you can see. There is a repetition of pattern. Okay. So there is a repetition of pattern. So periodic motion we have. Okay. Like the pendulum. Pendulum you might have seen. Okay. It moves, it keeps on repeating its position and motion, right? So that thing is known as periodic function. Is it clear?
Yes, sir.
So something or some mathematical value which is with some function which is having the same value after a certain period of time. That is also called periodic. Got it?
Yes, sir.
Maha, is it clear? Periodic.
Yes, sir.
So physical and chemical properties of the elements are the periodic function of their atomic masses, right? So it means when you arrange the elements in increasing order of the atomic masses, you will observe that the properties will get repeated. Got it?
Yes, sir.
Right?
Yes.
So when you arrange the elements in increasing order, you will see that the properties will get repeated. Got it? So this is clear. So what Mendeleev did? So Mendeleev actually did a very painstaking job, actually very difficult at that time. So he reacted the elements with oxygen and hydrogen, because oxygen can react with most of the elements at that time. And what he did is based on the compounds being formed, oxides being formed, hydrides being formed, he tried to figure out that what all elements form same type of oxides having same type of formula like Al2O3 and Cr2O3, like Na2O, K2O, okay, like MgO, barium oxide, calcium oxide. So he segregated the compounds on the basis of the oxides which are being formed and the hydrides which are being formed. He grouped together and also studied not only studied the compounds, but he also studied the properties of the various elements. Got it? And he saw regular variation in the properties. So that was actually very um, good thing at that time, okay, because at that time before that people were not aware of these repetition of properties of various elements, right? And he was so successful that he even predicted that there should be certain elements which were not there at his time, so he left gap in his periodic table for
But
the
how does he
elements
know
which,
that?
yeah, because suppose something is continuously varying, okay, some value is changing like 3, 5, right, 7, 9, and let's say suppose if 5 is not there, so 3, 7, 9, 11. So he thought that there must be certain element which was not there at his time. So he left a gap in place of 5. Okay, whatever the properties he may be studying, and the atomic number he was studying, so something was missing. He was not able to find that element at that his time. So he left a gap, and he also named that element based on the element above it. Gave an imaginary name and also predicted the properties of the element which was not discovered at his time. Okay, based on the position of the periodic table, its position in the periodic table, he was also able to predict its properties. Okay, got it. And you will be surprised to know that when these elements were discovered, okay, it was found that the elements after discovery they had many properties exactly same or similar which were predicted by the Mendeleev. Okay, so in a way this is a very big achievement. Got it? So Mendeleev periodic table is actually a very um, important achievement in chemistry, right? And but it was actually based on atomic masses. Okay, so that was the problem, little bit problem which we have. That was because of the atomic masses. Okay. So what the Mendeleev had in his periodic table, let me write it. Okay. And how the periodic table look like, what were the components of this periodic table? Okay, so because it is a table, so Mendeleev arranged the elements. What were the features of this table? So elements were arranged in horizontal rows. They were known as periods. 1 to 7. So today also we have 7 periods only. Okay, these are the periods. Got it? So periods are horizontal rows. Why they are called periods? Because when you arrange the elements in the increasing order of their atomic masses horizontally, after a particular atomic number, you will see that uh, you will see the periodic repetition of the properties. Is it clear? He not only arranged the elements in the horizontal rows, but he also put them in the vertical columns. Okay. So these vertical columns, they were known as group. So the elements were placed in vertical columns known as groups. Okay. These vertical columns, these groups were further divided into A and B. Excuse me. So these groups are actually further divided into uh, subgroups A and B. Got it? So now for in many periodic tables, modern periodic tables also you can see this effect. There are many modern periodic table. They have that A and B still written. Okay, and that is from the Mendeleev only. But now actually, as per the latest classification, they have been these actually are basically now we have group 1 to 18, right? 18. There are different groups which are allotted. So Mendeleev actually adopted A and B terminology, and today in the periodic table we can still see A and B. And we can still see in the modern periodic table also. Okay, these are the vertical groups. Got it? Is it clear?
Yes, sir.
Okay. So these are the vertical columns. So today we have 18 groups. A and B actually, these are the subgroups. But what are the other features of the Mendeleev periodic table? It was the first successful classification of the elements, all the elements that were known at that time. Not only the successful classification, as I told you, it also helped predicting the properties of the elements which were not there at his time. It helped in predicting the properties of Got it?
Yes, sir.
For example, and Mendeley will have gap in his table for those elements which were not there.
So how long is this class? 1 hour or 1.5 hours?
This is for 1.5 hours.
Okay.
Okay, so after aluminum there was a gap, and the element was called. He left a gap and he wrote the name as Eka aluminum, right? So and
Yes.
Eka, likewise there were four elements. Okay, Eka silicon, Eka boron. Right? And these were the elements in Sanskrit. It meant actually that after, okay, after aluminum. So later, when this element was discovered, and present day we know this element as gallium. The element was found. Silicon is Eka silicon is germanium. Got it. So these are the various advantages of the Mendeleev periodic table. Got it.
Yeah.
Apart from that, many atomic weights of the elements which were not correct at that time, they were corrected. So there were many elements which are not known at that time, and or if they were known, actually their atomic weight was incorrect at that time. So based on the properties, he figured out that their atomic weight should not be what was mentioned earlier. Instead, he predicted a new atomic weight, and that was found to be true. Got it. Example for beryllium. Okay. So it was a kind of very good initiative by Mendeleev, and which had a lot of advantages. And we are still using this pattern of the periodic table today also. So it acted like a precursor to the modern periodic table. But there were certain drawbacks also. It was because at that time everything was not known, and this achievement itself is a very big achievement and very difficult to do. But there were many things which were lacking behind, and that it was not technically advanced at that time. So many things were not correct also. So what were the demerits? Okay. So the demerits were, so where you should put the hydrogen? The position of hydrogen was uncertain.
Hydrogen is first.
Yeah, it is the first element. But today also there is a thing bit uh, because it resembles the alkali metal somehow, and to some extent it resembles the halogens also in properties. So that's why its position was uncertain. Today also it is the first element, but its color is not same as that of, if you see the color of the hydrogen, it will be different from that of the alkali metals which are placed below. It is not considered in the group one. along with the alkyl metal, it is there in the group 1.
I mean,
but not,
that's because it has only one proton, right?
yeah, no, that doesn't affect the properties much. Got it? It has one proton.
Okay.
That is also a different thing, which is not there in any element. No nucleus, just a single proton. But apart from that, the properties are resembling the alkyl metal, because just like alkyl metal, it has just one electron which can be removed. Like sodium also has the one valence electron, okay, outer electron I'm talking about. And if it gains one electron, like halogens, it can attain the electronic configuration of the next noble gas like helium. So in a way, but it is same. Some of the properties are resembling similar to that of alkyl metals, and some of the properties are similar to those of halogens. So its position was bit uncertain. Okay, today we have kept it separately by representing it in a different color, right? The next thing is Mendele's periodic table was based on atomic masses, okay? And atomic masses and isotopes of a single element, same element, suppose if you see, they have different masses. But no separate positions were allotted, in spite of having different masses, no separate places were allotted to isotopes. Though the periodic table was based on atomic masses only. But different elements, different isotopes of a single element were placed together, they were not placed separately, though they had different masses. Okay. So in a way, the Mendeleev is actually contradicting its own law. Got it? If the properties are the function of atomic masses, isotopes have different masses. So why the isotopes should be kept together? They should be kept separately. But that was not done. Okay, for a single metal, all its isotopes were placed together. Got it?
Yes.
No separate position. Were given to the isotopes of an element. Okay. Next is Mendeleev itself. Some places he relied more on properties, and at some places he himself has violated the atomic masses order. So I should write here is the order of atomic masses was not strictly followed. For example, we have argon. Its atomic masses is 39.94. It is 40 basically. Potassium atomic mass is 39. It's lower. It should be placed first, and argon should be placed later on. Okay. So that was not followed. Argon was placed before, in spite of having larger mass, it was placed before the potassium. So a lot of other places it was and like tellurium. it was placed before iodine. It is having a higher mass, but it is placed before iodine. Got it? So this is a violation of its own law of increasing order of atomic mass that is not strictly followed. He relied more on the properties of the compounds and the types of compound which were formed by these elements. So elements which were actually having similar properties, forming similar compound, they were put together. Okay. There is also one thing while classifying each group into subgroup A and B. What he did, in same group, he kept elements which were actually having entirely different properties. Is it clear? So different elements having different properties. Okay. So you can see in the periodic table, modern periodic table given in your NCERT. Right. Just a second. I will open it. So you can see that different elements are having entirely different properties, but they were actually in the different subgroup A and B, right? So, but actually they were placed together. Okay. So why they should be placed if they are having different properties, right? Just a second, let me show it to you so that you will have a clear idea of it. So this is the thing which we should know, and there were some elements, set of 3 elements. They were actually clubbed together. Okay. These are the earlier classifications and all, right? And this is the values of the properties of the unknown element. You can see that Eka aluminum, which was predicted by Mendeleev, and the gallium, which is found. Okay, can you see? This is the periodic table of the Mendeleev. So I hope you can see.
Yes.
Yeah.
Potassium and copper. Potassium and copper, you can see. Right? They are actually put together. Okay, in group 1 as A and B. Why they are actually placed aside from each other? Because one is A and B, another is B. Okay, so this is calcium and zinc. They were put together. Potassium and copper. Potassium is highly reactive. Okay. And the copper doesn't react with water. We know it is used to make cooking utensils and all. Silver and rubidium. they were placed together. Okay. And there is one more thing, if you notice that in group 8, you can see three elements were clubbed together: iron, cobalt, nickel, ruthenium, rhodium, palladium. They have similar properties, so there was no separate group assigned for these elements. Okay, is it clear? So these are the drawbacks
Yes.
of Mendeleev periodic table. One more thing, why so elements having different properties were kept in the same group with different subgroups like potassium and copper, like silver and rubidium. In group 8, 3 elements were put together. But these were the actually drawbacks, and the major drawback is why there is a repetition of properties. Why it is happening? All these are Mendeleev's observation. But what is the internal thing which is controlling the repetition of properties? Why the sodium and potassium are highly reactive and why they react with water in a way in which we observe them? Why there is a repetition of properties? That we are not able to see. Got it? That Mendeleev also was not able to explain. So, unable to explain the root cause or the fundamental cause of got it? Is it clear? So,
Yes.
but there are many positive things which we adopted and use it in our modern periodic. Got it? So these are some brief idea of the historical developments of the periodic table. Okay. So this is basically you can click the picture of for your reference for your notes, right?
Already written.
Yeah, so this is basically the first Doibrina type. There were many other attempts also. Okay.
So can I
So
show the last one?
yes, Doibrina triads, and then you have Newland law of octaves. Got it? Octave means 8. You have Lothermere curves. Okay, properties are plotted with respect to the atomic masses, increasing atomic masses. And Mendeleev's periodic table, this is the very important classification. Okay, so I hope this is clear. So Mendeleev, the concept of horizontal rows and column, that is very important. Okay, that has been adopted, okay, by us. Prediction of various elements which were not discovered at that time, and even the prediction of their properties, correction of atomic masses of various elements. So these are the achievements, okay. But because it was long back, and so there were many drawbacks also, demerits of the Mendeleev's periodic table, and these are the drawbacks of the Mendeleev periodic table. Got it? So let's move on to the modern periodic law. Very important. Got it? Modern periodic law
Yeah.
is actually we are using it today. So what is modern periodic law? Can you tell me, Nabila and Maha?
They use atomic number instead of atomic mass.
Yeah. Atomic number is actually the more fundamental property. Yes. Modern periodic law. So physical and chemical properties of the element are the periodic functions of their atomic numbers. So if I try to explain it in more detail, we can explain it in a layman way that when the elements are arranged in their increasing atomic numbers, we observe that their properties are getting repeated after certain atomic numbers. Okay. So these atomic numbers are known as magic numbers. You will see them. Okay. Magic numbers because they appear. Earlier people were not aware of a lot of things, so they used to think that some magic is happening after these atomic numbers. So that's why you see that there is a repetition of properties. Is it clear? So this is the
Okay.
modern periodic law. But today we know why the atomic number is more fundamental property than atomic mass. Can you explain it to me? Maha and Nabila, both of you can try.
It's more unique because mass can repeat itself, but the number is unique for each element.
Yeah, but if something is unique, like melting point may also be unique
Mm.
for elements. But if something is unique, but how that is governing the properties, that we need to think. That is true, it is unique and all. But why atomic number is more responsible for the change in properties of the elements, not the atomic mass? Why?
The arrangement.
Pardon?
Is it the arrangement?
Yes, it is. Atomic number is basically, it is the number of protons. Got it? But we are not interested much in the protons. But actually, whatever the number of protons are there, that will be equal to the number of electrons also. Is it clear?
Yeah.
And these electrons are basically responsible for the chemical reactions. Okay, why the chemical reactions are happening? Atomic mass is actually, it is the mass of the nucleus. Okay, protons and neutron. Neutron doesn't have any role. They are neutral in the properties and all. Okay. So in a neutral atom, not in iron the electrons can change. They can be more or less number of electrons. But actually, it is the ultimately electrons are participating in a chemical reaction. Okay, because they are put into various shells as we have seen in the atomic structure chapter. So they only are responsible for the chemical properties. Okay. The valence electron. So when you put these when you increase the elements in increasing atomic number, you see that the electrons are being added to various shells and subshells. Okay, and there is a repetition of electronic configuration of the valence electrons And because of that repetition, you see that there is a repetition of chemical behavior. In chemical behavior, you see there is a repetition. The type of chemical reactions, the pattern of chemical reaction, they are being repeated. Got it? So I hope this is clear to you. Got it? But who gave you the idea? Who gave us the idea of that? But this is a very simple thing. But earlier people were not aware of these things and all. So who gave the idea? Mosley's law. Mosley's experiment. So what Mosley did, Mosley studied the, so he actually, the cathode rays we have seen. So he directed the cathode rays on the heavy metal. What were actually cathode rays?
Positive.
No, cathode rays were fast moving electron. Anode rays were positively charged. Got it? And cathode
Oh, yeah.
rays were actually targeted on heavy metals, right? Heavy metal surfaces. So what was observed? Mosley observed emission of some unknown rays, electromagnetic radiations, and he named them as, because they were unknown, X-rays. Got it? So today we know that they are X-rays, and but they still, then we know the properties of X-rays, but still that name is being still is used, right? So cathode rays, when they hit a surface of a heavy metal like tungsten, right? Okay, rhodium, rhodium, iridium. These are heavy metals, and you see emission of X-rays. Got it? So how this Mosley's experiment and X-rays are responsible for the discovery of atomic number as being responsible for the fundamental properties of the elements. Okay. So what Mosley studied, the frequency of the X-rays. Frequency is represented by nu. Got it? Frequency of the X-rays. And over function of atomic numbers. Got it? So from that he got the idea. So this is the frequency of the X-rays which were emitted. They were equal to some function was found out, and the frequency of the X-rays, square root of the frequency, and it was observed that for various materials, they were actually varying with respect to their atomic numbers, Z. So this draws the attention of various scientists and the people which were working on the periodic properties. That atomic number is basically maybe the more fundamental properties. This was the time when nothing was known, or very less knowledge was there regarding the structure of the atom and all. The electronic configuration, they were not known as much in detail. So this experiment actually let the scientists think that maybe the atomic number is the more fundamental property than the atomic mass. But today we know it is where today we have lot much knowledge than people that were there at that time. We know that the atomic number, the shells are there, and there is a repetition of every time a new shell starts. We have seen N plus L rule, Pauli's exclusion principle, Holmes rule. Okay, we have seen how the subshells are being filled in the atomic structure chapter, and we have seen that once the shell is completed, then again you have a new shell starting from the S subshell, right? And it will have 1, 2, 3 electrons. Okay, so we know that there is a repetition of electronic configuration, and there is a repetition of electronic configuration. Which one? The outer valence shell electronic configuration. That is most important, because the valence electrons are going to interact with the outer world. Okay, that's how they only participate in chemical reactions, ionization, okay, all bond formation, everything. So they are the real thing which is getting repeated, and that's why the properties are being repeated, and the electronic configuration is because of the number of protons. Got it? So now we have the more fundamental understanding of the repetition of properties. Is it clear or not? So
Yes.
modern periodic law, is it clear to everyone? And who gave the idea? You will have this whole thing in detail in X-ray, but not in chemistry, in physics, modern physics in class 12. Got it? Modern physics will also have this whole explanation and all. Is it clear or not? Got it?
Yes, sir.
So cathode ray experiment and all this cathode ray experiment actually led to the discovery of X-rays also, and that led to the discovery of the modern periodic law. Okay, now in the next class, we will be discussing the modern periodic table. Okay, how the elements were arranged in it, what the basic idea, but the basic idea is actually very much familiar to us from the atomic structure chapter and from today's chapter of the Mendeleev periodic table. Okay, and we will also see many new things, and then we will move on to the properties, which are very important and which play a key role in the reactions of various elements. Okay, periodic properties, then we will see how these atomic size, ionization energies, electronegativity, okay, all these things, and electron gain enthalpy, they are changing, and what do they mean, what their significance is for us. Okay, so let me end today's class. Okay, just go through an NCERT that has a lot of detailed explanations. Okay, just go through it, do the intakes problem, just read your NCERT up to that Mendeleev periodic table. Read that. Okay, if anything is not clear, just ask me in the next class. So let me end today's class. Bye bye everyone.